Hi, my name is Muhammad Fikri Naim bin Muhammad Yusri, and today I will explain about determinant of a matrix. Let's start with a basic 2 by 2 matrix. Here we have A, B, C and D in a matrix form. Okay, the way you do this determinant is you have to cross multiply this A, D, B and C, and you should write it as A times D minus B times C. Okay, now let's move on how to calculate a determinant of a 3 by 3 matrix. Now, the first step you have to do, if you have to eliminate the first row and the first column, and you have this 2 by 2 leftover matrix, and for the first row you have to take A1, and you can write it as A1 times B2 C2 B3 C3 minus. Okay, for the next step we have to eliminate the first row and the second column. Then we'll have this 2 by 2 leftover matrix, and for the second row we have to take B1, and you can write it as minus B1 times A2 C2 A3 C3 plus, for the third step we have to eliminate the first row and the third column, and we will have this 2 by 2 leftover matrix, and for the second step we have to take C1 and write it as C1 times A2 B2 A3 B3. Okay, now let's move on to the example for this question. The first step you have to do is to eliminate the first row and the first column, and take this 2 by 2 leftover matrix and write it as 2 times 7 6 1 9 minus. Do the second step, eliminate the first row and the second column, and take the leftover matrix and take 4 as our second step. Write it as minus 4 times 5 6 negative 8 9 plus. Apply the third step, which is eliminate the first row and the third column. Take this 2 by 2 matrix and take negative 3, and we can write it as negative 3 times 5 7 negative 8 1. From there we have to apply our previous knowledge on 2 by 2 matrix, where we have to cross multiply this number. Okay, and then if you do your calculation correctly, you should get negative 441 as a determinant for this 3 by 3 matrix. That's all from me. Thank you.
Okay, Assalamualaikum. Hello. So I will continue the topic determinant, which is minor and cofactor. So first thing, how we know the minor in the matrix. Minor we can call M, for the formula is Mij, or M row and row column N. Okay, so we can see the example. I will show the example. For the A11, we know it is row 1 and column 1. What's the minor for the A11? So minor for A11 we used to be like this, M11. So first we circle the row 1 and the column 1. So we'll look at the dominant that dominating the four element that left. We neglect the circle element for the row 1 and column 1, and we times this, okay, like this. So A22 times A33 minus A23 times A32. So this is how we find the minor for the A11 element. I will show the next second example, which is A22. So we circle the A22 or A22 row 2, A22 column 2. So we want to find the minor for the row 2 and column 2. So we neglect the in the circle, exclude the circle, and look at the remaining element. So we multiple and minus, which is A11 times with A33 minus A13 times A31. So that's the way how we find the minor. We look at the cofactor after the minor. So cofactor, it has a relation between minor and the matrix. Cofactor, we can say that C row n and column n, and for the formula is Cj equal to -1 I plus j times with minor ij. So this is the formula to find the cofactor. Okay, we go to the example, which is A11. A11, we know the row 1 and column 1. So first we use to find the cofactor of row 1 and column 1, or element A11. So first we look for the formula, which is -1 the power of I plus j, which is 1 plus 1, times the minor. We can see before this, like we circle the row 1 and column 1, and we neglect the circle. We see the dominant or element remaining element. We multiple minus multiple, which is A22 times A33 minus A23 times A32. So this is the formula of cofactor. Another example is we can see is for the A22 element. What the cofactor of A22? So C22 is we know the formula is -1 the power of 2 plus 2, multiple with minor of 2. We neglect the circle and look at the remaining element, which is this A11 times A33 minus A13 times A31. So this is how we find the cofactor for the matrix or element in the matrix. Final is C22, F1, 4, and A11, A33 minus A13, A31. We can conclude is Cj equal to F1 Ij multiple with minor Ij. So this is a formula that you need to remember to find the cofactor. So thank you.
Hello and Assalamualaikum. My name is Muhammad Hakim Azman, and in this video I will explain about cofactor expansion. So in previous explanation we know that cofactor about formula, which is Cij equal to -1 I plus j minus Ij. So from that formula we can use that on cofactor expansion. So in cofactor expansion we have two type, which is along column and along row. So from the formula for column in cofactor expansion, the formula is the summation of Aij and capital Aij. For in the row, summation of Aij and Cij. So from that formula we can derive that into the cofactor formula. So cofactor expansion we get is Cij equal to -1 I plus j determinant Aij. So for example, use cofactor expansion to find this determinant. So by using cofactor expansion across row, so from the formula we can use that and into the question. So the answer is A11 C11 plus A12 C12 plus A13 C13. So we can see from the label, from the color, for yellow is a 1 1, for green is for 1 2, so orange 1 3. So we expand that for the formula, so we can get the determinant. So at C11 we have -3 0 4 1, -3 0 4 1. For C12 we have 4 0 2 1, and Ci3 we get 4 -3 2 4. So we plug that formula and we get the answer. So the final answer is -20 plus 22, we get 2. So next, I will share about the method which is eliminate zero method. So from the matrix we get from 4 by 4 matrix. So first, from this method we must choose column or row that have highest amount of 0. So from the matrix we can see from the label green, which is row 3. So from row 3 we get the highest amount of 0. So from the row we can use the formula cofactor expansion. So the answer is A31 C31 plus A32 C32 plus A33 C33 plus A34 C34. So we plug them into the formula. So from 3 1 which is row 3 column 1, so we get the 2 2, determinant 0, 0, 5, 7, 2, negative 5, 3, 1, 8. So for the next A32 and C32, we know that the A value for 32, A32 is 0. So we know that the final answer is 0 for A32, C32. Same for A33 and C33, 0. And A34 and C34, 0. So for A31 and C31, that we have that value, just that value. So we must apply this eliminate 0 method again. We choose where is 0, so we choose row 1. So from row 1, we can apply the formula of cofactor expansion. So 2 in bracket A11 C11 plus A12 C12 plus A13 C13. So we plug them into the formula. So we know that A11 and C11 is 0, same to A12 C12, 0. So A13 and C13, we have the value 5 minus 1 to power 1 plus 3, determinant 7, 2, 3, 1. So the final answer is 2 times 5 equal to 10. So from this method, we can get the determinant for matrix, which is eliminate 0 method. So that's all for me for subtopic cofactor expansion. Till then, thank you.